Alright, so welcome to another lesson. Um, in this lesson, we are going to look at the introduction to functions. Okay, so specifically in this lesson, our objectives are to define a function, okay, and then to check if a given expression or a given relation is a function, okay, and then three, we are going to check if a function is one-to-one. Okay, and then number four, we are going to look at how to evaluate a function at a given value. Okay, okay, so the first thing, we are going to define what a function is. Okay, so before we even define what a function is, okay, we need to know that a function is simply a special type of relation. Okay, so this is a special type of relation, and we know that a relation is just a relationship between two things, two items. Okay, so we know that a relation is just an association. Okay, so we can say it's a rule that associates, okay, elements of two sets. So for example, if I have my first set there, let's say this is set X, and then it has 1 2 3, okay, and then here I have another set which is set Y, okay, and then I say this set Y has A, B and C. Okay, so we know that this relation here will just be a rule that will associate the elements of this set X to the elements of this set what? Y. So we can have mappings between these two sets. We can have this one going to the A, these two going to the B, these three going to the C. So we see that a relation is just a rule, okay, that associates elements of two different what sets there. Okay, so that's what a relation is, and we know that this relation, we have different types of relations. Okay, we have one-to-one relations like this one here, the one I drew. Okay, and then we have one-to-many. Okay, so for example, uh, if our relation here was like this, okay, so let's say 1 is mapped to A, okay, and it's also mapped to B, okay, and then this 2 is also mapped to B, this 3 is mapped to C. So we can see that we have one element of set X being mapped to two elements of set Y, so that will be called a one to many relation. Okay, and then apart from one to one and one to many relation, we also have a many to many relation. So let's say for example we have this. Okay, so many to many relation, it means we have this one element of set X, okay, being mapped maybe to two elements of set Y. Okay, and then also I have that from one here. Okay, let me change the color. From one here I'm going to maybe B, okay, and then that B is also mapped to 3 like that. Okay, so we know that such type of a relation, it will be called a what? A many to many, because we have many elements of the first set going to many elements of the second set, and also vice versa. Okay, so this here is a many to many relation. Okay, so the last type now of relation that we have is a many to one. So many to one, it means if this one goes to A, I'll also say this two goes to A as well. Okay, and then these three here can go maybe to the three there. So we have many, we have these two here, we are saying many. Okay, so many 1 and 2 are going to the same element, which is A, so that will be a relation that will call as one as many to one, I mean. Okay, so now when we talk about a function will be a special type of relation. Okay, so why is it special? Why is this function so special? Okay, that it has to be different from the other relations. Okay, so this function we are saying is a special type of relation. Okay, so what's the definition of a function? Okay, so by definition you say that a function, okay, a function is a relation, okay, such that it's a relation such that for each, okay, for each first component, for each first component, okay, of the first set, so we can write of the first set here, of the first set, okay, there is, okay, so this is where it becomes special. There is one and only one. Okay, there is one and only one second component. Okay, so what does this mean? It means that if you have elements, okay, in the first set, for example, this is the first set here, let's say x, we have 1 2 3. Okay, so what this definition means is that, okay, for each of these elements in the first set, okay, you have another element in the second set that where these elements in the first set are being mapped to. Okay, so in short, all the elements in the first set here should have an image in the other set. Okay, so that's the first part of the definition. Okay, and then the image that this element should have, okay, should be one and only what? One. Okay, should be one and only one. So what does that mean? It means each element here should be mapped to a unique, okay, to a unique element of the other set. Okay, so I have examples down here. So let me bring this guy up. Okay, I have examples there that will help us understand this definition. Okay, so let me make it a bit bigger. I hope you are seeing this. Okay, so that question there you are seeing, they are saying what has happened now? Okay, let me just erase the definition. Okay, so in that question, in the picture that I've shared, they're saying state which of the following relations given by the arrow diagrams below are functions. Okay, so we said we have two conditions to satisfy, okay, if that certain relation is a function. So the first one is that each element of the first set should have an image in the other set, and then two is that that image should be unique. Okay, that image should be unique. So now the first question here, they're saying state which of the following relations given by the arrow diagrams below are functions. So the first one here, I'm going to ask you guys, is the first one a function or it's not a function? Hello? Is the first one a function or it's not a function? Come on, guys. What's the answer there? The first one there, is it a function or it's not a function? According to my explanation of a definition, is that a function there or it's not a function? What can you say?
It's a function
Okay, so why do you say it's a function?
because each element from one side
Mm-hmm.
does all a corresponding element from to the other side.
Exactly. Okay, so we can see that all these elements in the first set, A, B, C, and D, okay, they all have images in the second set. So this one is mapped to that one, this one is mapped to that one, this one is mapped to that one, this one is mapped to that one. And okay, and the other condition is that okay, each element of the first set here okay should be mapped to one and only one image. Okay, so we see that for all the elements in the first set here, okay, for all the elements in the first set here, it's only mapped to one image like that. Okay, so if for example, okay, if for example we had such a mapping like this, so this A we've seen it's mapping 1, right? So if for example I say again this A maps 2 like that, okay, this here will not be a function. Why? Because one of the first elements of the first set has two images like that. Okay, so this will make it not be a function. So for something to be a function, by definition, all the elements in the first set must be mapped to some element in the second set. Okay, and then each element should be mapped to only one output. Okay, should only be mapped to one output. Okay, so only one output. So immediately you have two outputs, like in this case where I've illustrated, then it becomes a non-function. Okay, so the first one there we are going to say it's a function, and then when we go to the second one here, is this a function? Let's participate. Is this a function here?
No.
No. Okay, why is it not a function?
Because we've got some members there which do not have a reflection in the other set.
Exactly. Okay, so we have this guy here, the B. It doesn't have anything, okay, where it's mapping to. So this makes this not to be a function. So this one is not. This one we said yes, it's a function. Okay. All right. So we're understanding the definition bit by bit. And then what about this third one here? Is this a function or it's not a function?
Not a function.
It's not a function. Why is it not a function?
If I remember very well, in your definition, you said each member in the first set is going to have its own unique member in the other set. And if you look at this one here,
Mhm.
finding that all the members in the first set are pointing to one member.
Okay. All right, so that's unique. You have to understand it. Okay, so by unique I mean that this first element here should only be mapped to one. Okay, that's what I mean by unique. So this one on the third one there is actually a function. Okay, why? Because the first condition is that okay, each element of this set here is mapped. We can see it as two more arrows that they are going somewhere, right? So they are all mapped to 4. But this 4 here is unique to this A. We see that this A here is not mapped to any other element. Even this B is only mapped to 4. So it's mapped to any other element. Even this C is only mapped to 4. It's not mapped to any other element. Even this D is not mapped to any other element but 4. So the two conditions they are satisfied. One is that all the elements of the first set have been mapped. That's the first condition. Okay, and then all the elements in the first set do not have more than one image. Okay, so this one here on the third one here, it's a function. Okay, so by unique I mean this here should not be mapped to two different elements in the second set. Okay, so I hope we've understood the definition. Okay, so I'll just go through over the same definition of a function. So take note that each element of the first set okay should have an image in the second set. Okay, and then 2, some elements in the set B may not be connected to any object in the set A. Okay, so for example these ones here, these elements are not connected to anything in set A, but this is still a function. Okay, but if it was the opposite set, the opposite case where you have some elements of this first set not being mapped, then that is not a function. Okay, right? That's the second point. And then the third point is that each object or each element in the first set here, okay, should only be mapped to one element in the other set. Okay, it doesn't matter if it's the same element where all these are going, as long as this element here is just mapped to one element in the second what set, and then that becomes a function. So that's the definition. So two important points there. Okay, all right, so we can move now to talk about how to check if a certain relation, okay, is a function. Okay, so what do we use? Okay, what do you use if you want to check if a certain relation is a function or it's not? Okay, so we are going to be using what we call as the we're going to be using what we call as the vertical, okay, the vertical line test. Okay, we're going to be using the vertical line test. So what this test is that if I draw a vertical line anywhere on my graph, okay, of a certain function, if that line touches the graph at one point, then it's a function. If it touches the graph at 2 points, then it's not a function. Okay, so I'll just use some examples here for the sake of you guys getting the concept. Okay, don't worry about the how to sketch. We are going to cover that as we move in this topic. So I have two lines here. Okay, I have two graphs here, or two functions. So y is equals to x is the function, and then I have another one, y is equals to x squared. Okay, so if I would draw this guy here on the x or y plane to be like this, so this will be my x or y plane, and then this here will be my y, this here will be my x. Okay, so if I draw the line y is equals to x, it will just be this line here. Okay, this will be the y is equals to x. Okay, so now on this graph we are going to apply a vertical line. So anywhere where you want to draw a vertical line, so a vertical line goes up and down, guys. Okay, so if I draw a line like that, even here, even there, okay, anywhere where I want to draw this line, if this line touches this curve for this function at only one point, then we conclude that whatever we've been given here is a what? Is a function. Okay, so this was the first example, and then this is a quadratic equation. Okay, you will know how to graph them, but in this lesson I'm just trying to stress the point of how to know if a certain function is a certain relation is a function. So this quadratic equation has this graph here, it comes there and then it goes like that. Okay, so if I draw a vertical line here anywhere here, we see that this vertical line will just cancel this curve at one point like that. It will just be that point or that point or that point. So we can draw the vertical line anywhere. So since this vertical line is cutting this curve at only one point, we conclude that this guy here is what? A one-to-one relation. Okay, let me give more examples on this one. So let me give an example of a certain equation which is not a function. Okay, so we'll see that the vertical line will cut that function at more than one point. Okay, so let's say I have number 3, I have the equation x squared plus y squared is equals to 1. So this equation is the equation of a circle, okay, with radius 1. So how to graph it? I said don't worry, we are going to cover that. Okay, so here I'm just stressing out the point of how to know if it's a function or it's not. So if this is my x or y plane, okay, and then I have this function here, this is the equation of a circle, so it will be something like this. Okay, so now if I apply the vertical line test on this graph here, okay, how many times is that vertical line going to cut this curve? So if I draw a vertical line like that, even if I draw it like that, you see that this vertical line will cut this curve at 2 points like that. Okay, so immediately you see that the vertical line is cutting the curve at 2 points. Okay, just know that that function is not. Okay, that relation, I mean, okay, that relation is not a function. Okay, so this is how you can know. Okay, but the questions where they're asking you to prove if a relation is a function or not, they are not that much common. Okay, so this is an example. I wanted you guys to know how you can find out, given a curve of a relation, if it's a function or it's not a function. Okay, and then moving on, we are going to talk about how to check if a function is one to one. Okay, so we have two methods. The first one is called the graphical method. Okay, the graphical method, and then the second one is called the algebraic method. Okay, so under the graphical method, we use what we call as the horizontal line test. Remember, to check if it's a function, we use the vertical line test. Okay, but here we're going to use the horizontal line test. Okay, horizontal line and then test. This is what we are going to use here. Okay, so given any curve, we can just draw a horizontal line and see if that horizontal line is going to touch that curve at only one point. Okay, then we conclude that that function is one to one. And then if that horizontal line is going to touch that curve at 2 points, then we have to conclude that uh, function is not one to one. Okay, so that's how we use this vertical line test. So let me give a quick example here before we go to the algebraic. So let's say we had that same line there where we had the x is equals to y. So x is equals to y is this curve here. So this is our x is equals to y. So horizontal line test, it means I can draw any horizontal line here. Okay, so we see that this horizontal line that I'm drawing is cutting this curve at only what? 1 point. Okay, it's only cutting this curve at 1 point like that. So it means y is equals to x is a one to one function. Okay, what if I draw the one for the quadratic that we drew there? Okay, so x squared. Okay, so this is a quadratic. We'll get to know how to draw it later. Okay, but this is just for sake of you understanding. Okay, so if this is my x squared, right? So if I draw a horizontal line anywhere here, let's say there, okay, we see that this horizontal line is going to cut this curve at 2 points. Okay, so immediately you see that the horizontal line is cutting this curve at 2 points. Okay, you conclude that this equation here is not one to one. Okay, not one to one. So that tells you that any quadratic equation that you may think of, okay, any quadratic equation will never be one to one. So when you're given questions and you just see x squared somewhere, just know that that equation is not one to one, no matter what. Okay, any quadratic equation will never be one to one. So that's how you can use the graphical method. Okay, and then now let's talk about the algebraic method. So the algebraic method is what you'll be mostly using, you guys. Okay, because you haven't yet learned the skills of graphing. Okay, so how do we use this algebraic method here? Okay, how do we use the algebraic method? Okay, so the algebraic method is based on this definition. So if you have maybe a function f of x is equals to, okay, let me say 3x minus 5. Okay, so we can determine if this function here is one to one by finding f of a, okay, which will be equals to f of b. Okay, and then from this expression f of a is equals to f of b, if we are able to come up with a is equals to b, okay, if we're able to come up with this expression from these two functions here, then we conclude that our function here is what? One to one. Okay, so let's use this same example here to find if it's one to one. So let's find f of a. So f of a is simply replacing where there's x there, we're now putting what? A. So it will be f of a is equals to 3a minus 5, and then f of b will be equals to 3b minus 5. Okay, so now let's equate f of a to f of b. So it will be 3a minus 5 is equals to 3b minus 5. Okay, so what would this give you? So you are remaining with 3a this side is equals to 3b minus 5, and then this minus 5 goes to the right hand side to become a plus 5. So we see that this here is going to give us a 0. Okay, so what are we going to remain with? We are going to remain with 3a is equals to 3b. So just divide both sides. Here you divide by 3, even here you divide by 3. What are you going to remain with? We are going to remain with a is equals to b. So this is the method that you guys will be mostly be using. Okay, so from our f of a and f of b, we see that we are able to come up with a is equals to b. Okay, so this here proves that the function is one-to-one. So that's how you use the algebraic method. Okay, let's do another example. Okay, let's do another example. Okay, let me put another example here. So let's say we have this example, f of x is equals to x squared. So is this function here, okay, is this function here a one-to-one function? Okay, it's not. Okay, it's simply not a one-to-one function. But how are we going to prove it? Okay, so let's find f of a. So f of a will be wherever there's x, we're just putting a squared. F of b will just be b squared. Okay, so now let's equate f of a to f of b. So f of a is a squared equals to b squared. Okay, so from this expression here, are we able to get that a is equals to b? Okay, so we are going to square root. Even this side we are going to square root. Now notice that, okay, immediately you square root. Okay, if you are the one who has introduced the square root in the question, okay, if you are the one who has introduced the square root in the question, okay, then it means the answer that you are going to get here will be plus or minus. Okay, then these two cancels with the root, so we have a is equals to, even here because it's us who introduced this root, we are going to have plus or minus b. Okay, so now from this plus or minus, a is equals to plus or minus b. Okay, what are we going to have? Okay, what are we going to have? We see that, okay, we see that we are going to have a is equals to b. If I get positive positive, okay, I can also get negative negative, so I have a is equals to minus b from this same expression here, and then I can also get positive a is equals to minus b, and then I can also get minus a is equals to what? B. So you see that from this expression here, we end up with four formulas. Okay, so we have this a is equals to b that we want, and then we have other additional conditions that we are getting there. Okay, so because we are getting all these other conditional additions, it means this condition here is not the only one. Okay, so if it's not the only one, then definitely that function is not one-to-one. So you are going to say this function is not one-to-one. Why? You pick either this condition or this condition here, because this one here is the same as the one on top, because just divide by -1 both sides, you get the same. So you say this function here is not one-to-one because I can get a is equals to minus b, or you can say minus a is equals to b. Okay, so this here is not one-to-one. Okay, so any questions there, guys? Any questions? Okay, no questions. Let's look at another example on this, and then we can move now. Okay, so now let's look at this example here. So let's say, for example, I have this function. Okay, let's say for example we have this function. So f of x is equals to, and then we have x to the power 3 minus x to the power, minus 4x. So is this here a one-to-one function? Okay, so the first thing is to find your f of a, which will just be a to the power 3 minus 4a, and then f of b will be equals to b to the power 3 minus 4b. Then let's equate this f of a to f of b. So it will be a to the power 3 minus 4a is equals to b to the power 3 minus 4b. Okay, so from here, what are we going to have? Okay, from there, what are we going to have? Okay, so we see that from here we can't simplify any further. Okay, there's nothing that we can do here. There's simply nothing that we can do. Okay, there's simply nothing that we can do here. Or even if we try, let's try. Let's say we factorize a here, we're going to get a squared minus 4 is equals to, even here we factorize b. Okay, so when we factorize b here, we're going to get what? We're going to get b, and then here it will be b squared minus 4. Okay, so this is what we get there. Okay, we see that there's no way we are going to equate a is equals to b here. There is no way. Okay, there's no way where we can find this condition. So we conclude that this function here is not one-to-one. Okay, so that function there is not one-to-one. So any questions on the one-to-one concept? Any concepts? Any questions there, guys?
So, sir, does it mean that it's one to more since it's not one to one, or there's another way to find more one to more?
Okay, so what you're saying is basically it depends. It depends with the function that you have. Okay, but they will never ask you to find if a function is many to one or one to many. No. Okay, so it means this one here is it is a many to many. This function here, when you graph it, you see that it will be a many to many. So because this one here, it has a power 3 somewhere there. Okay, it has a power 3. So in general, if you have a power 3 there and then you have x somewhere there, okay, it means you can have something like this. Okay, so when you look at this one here, the horizontal line graph will come like that. You see that it touches this curve at more than one. You've seen it, more than one. So it's not a one-to-one function. Okay, but it can either be a many to one, or it can be many. It can be many to one, or it can be one to many. Okay, it doesn't matter. You don't have to know that. Okay, your focus is just to test if it is one to one. Okay, all right. So unless there are any other question there. Okay, so now let's try this last one here. Let's try this last one. So this last one is also a cube root, but it does not have any other expression with x. Okay, let's continue. So the other one I was saying is f of x is equals to x to the power 3 and then plus 2. So this one here, you notice that it does not have any other x here. So if it does not have any other x, just know that it will be one to one, because its curve will just be like this, to be like that. Okay, so if you draw any horizontal line there, to just be touching the curve at one point. So if you find f of a, it will be a to the power 3 plus 2 is equals to, what is f of b? F of b will be b to the power 3 plus 2. So this will be a to the power 3 is equals to b to the power 3 plus 2 minus 2. So you see that this part here becomes 0. So we have a to the power 3 is equals to b to the power 3. So we just introduce a cube root here. Even there we introduce a cube root. So now a cube root is unique. Okay, once you introduce a cube root there, you are not going to get plus or minus. This only happens, okay, when you have a square like that. So for a cube root or any root that is not even, you are just going to get this cube root to cancel with the 3, so you have a is equals to this cube root to cancel with the 3, you have b. So you are able to get your a is equals to b here, and this proves that your function there is what? 1-to-1. Okay, so we've talked about what one-to-one functions are, and then now we can talk about evaluating functions. Okay, so evaluating functions is what you guys were doing at your grade 12. So for example, I have f of x is equals to, let me say 2x minus 5, and then they ask you find f of 2. You remember what you are doing? Okay, we are just going to say f of 2 is equals to 2, and then wherever there's x we put x, minus 5, and then this will give us 4 minus 5, which will give us minus 1. Okay, we can also find maybe f of 1. Okay, so evaluating is not difficult. So f of 1 will just simply be equals to 2, whether there's x, now we are putting 1, so 1, then minus 5 is equals to, so this will be 2 minus 5 is equals to minus 3, like that. Okay, so evaluating function, I don't think it's a problem to you guys unless otherwise. Okay, so that's it for this introduction to functions. Okay, and then in the next class we are going to go now deeper into these functions. Okay, we are going to discuss the even and the odd functions. We are going to discuss the inverse of the function, and note that a function can only have an inverse if it's 1-to-1. Okay, so we need to know how to apply that, okay, and then find the inverse. We are also going to talk about the composite functions, okay, in the next lesson. So composite functions, I know we did part of this at grade 12, so I don't expect you guys to have a lot of problems on the composite functions. Okay, and then here we have an assignment that I've put for you guys. Okay, let me just do this so you can capture it, and then you try to solve it. Okay, so what is the assignment here? Okay, so this is the assignment. I've given about 4 questions. Okay, so the first one is state which of the following relations given by the arrow diagrams below are what? Are functions. So I've taught you how to identify, and then here I've given you a function, and then I want you to evaluate it at this value, that value, and then solve this equation here. Okay, and then which of these graphs represents functions that are 1-to-1. So I've taught you how to do it on a graph, right? So I expect you guys to answer that. And then the fourth one is just saying show whether the following functions are 1-to-1 or not. So I have this 1, 2, 3, 4, 5, 6. Okay, so as long as you're able to do this, then no question will be difficult to you guys. Okay, so this is the assignment. I'll send it in the group, so you guys should work on it. Okay, so any other question? Any other question, guys? Okay, so if there are no any other questions, I'm going to end here today. Have a blessed night.